Okay, so today we're going to be talking about recursion, which is a mathematical concept that is used to solve many problems on the AIMC and AIME. So, what is recursion? A recursive relationship is when the terms of a sequence are related to each other. So, for example, we could have something like the sequence A sub n, where the nth term of the sequence is equal to 2 times the n minus 1th term. And we would also need a starting condition. So let's say a sub 1, which is the first term, is equal to 2. Then what is a sub 2? Well, this is when n is equal to 2. And if we follow this rule, a sub n equals 2 times a sub n minus 1, then a sub 2 is equal to 2 times a sub 1. But we know a sub 1 is equal to 2. So this is equal to 4. And similarly, we know that a sub 3 would be equal to 8, and a sub 4 is equal to 16, and so on. Now, in contrast to a recursive formula, which is what this is known as, there's also something known as the explicit formula, which is more commonly used. The explicit formula is basically a way to just directly relate or directly compute the value of some term. In this case, the recursive or the explicit formula for the sequence would be a sub n is equal to 2 to the power of n. And this could be trivially proved using induction. So what this means is that the nth term of the sequence A is equal to 2 to the power of n. So for example, a sub 1 is equal to 2 to the power of 1, which is 2. A sub 2 is equal to 2 to the power of 2, which is 4, and so on. One of the most famous recursive sequences is known as the Fibonacci sequence, which probably many of you have heard of already. So the Fibonacci sequence is basically, it says that any term in the sequence is the sum of the previous two terms. So it goes something like this, 0, 1, 1, 2, 3, 5, 8, 13, and so on. So if you look at the sequence, 13 is the sum of 5 plus 8, 8 is the sum of 3 plus 5, 5 is the sum of 2 plus 3, and so on. And the way we would write this is f of n, which is the nth term of the Fibonacci sequence, is the sum of the term n minus 1 and the term n minus 2. And there's also an explicit formula that is used to compute the Fibonacci sequence, but it's super complicated. It's known as Benet's formula. If you're interested, you can search it up. Okay, so now that we know what recursion is, let's try to solve a problem using this idea. So this problem states, a frog wants to climb a 10-step staircase, climbing 1 or 2 steps at a time. How many ways can the frog climb the staircase? Okay, so this problem could probably be solved using concepts like principle of inclusion-exclusion or just simple combinatorics, but I want to use recursion because it's much easier. So to solve this, we first need a definition. So let's say f sub n is equal to the number of ways to climb an n-step staircase. So what we're looking for would be the term f sub 10, because that would be the number of ways to climb in a 10-step staircase. And now what we need is a recursive formula which relates the terms of the sequence. So let's say we have an n-step staircase, something like this, and I'll just write out the previous two terms as well. where we have the step 1, step 2, step 3, step 4, step 5, the n minus second step, the n minus first step, and then the nth step, which is the top of the staircase. How many ways are there to get to this nth step? Well, you can either get to the nth step from n minus 1, where you hop one step, or you can get to the nth step from the n minus second step by hopping 2 steps, because the frog can climb 1 or 2 steps at a time. So the number of ways to get to this nth step is equal to the number of ways to get to the n minus first step plus the n minus second step, because from the n minus first step, there's one way to get to the nth step, and then from the n minus second step, you can also get to the nth step in one way. And that's how we get our recursive formula. Now that we have our definition and the formula, all we have to do is compute the first few terms, and then repeatedly apply this formula until we get to what we want, which is f sub 10. So how many ways are there to get to the first step? Well, there's only one way. You can only go one step. So f sub 1 is 1. How many ways are there to get to the second step? Well, let's say the frog starts here, you can either hop twice or climb one steps twice, which would look something like this, or you can just hop 2 steps and go directly to the second step. So that would be 2 ways. Okay, and now we're done computing our first few terms, because we can just use our recursive formula, which is f sub n equals f sub n minus 1 plus f sub n minus 2, to compute the rest. So we know f sub 3 is equal to 1 plus 2, which is 3. F sub 4 is 2 plus 3 is 5. F sub 5 is 5 plus 3 is 8. F sub 6 is 13. F sub 7 is 8 plus 13, which is 21. F sub 8 is 13 plus 21 is 34. F sub 9 is 55. And finally, F sub 10 is 89. So our answer is there are 89 ways for the frog to get to the top of the staircase. All right. Now let's move on to a slightly harder problem. So this is the 2007 AMC 12A number 25. It says, call a set of integers spacey if it contains no more than 1 out of any 3 consecutive integers. How many subsets of the set 1, 2, 3, 4, 5, all the way to 12 are spacey? So again, let's start with a rule and then try to find a recursive formula. Or not a rule, sorry, a definition. So let's say, again, f sub n are the number of spacey subsets of a set with elements 1, 2, 3, all the way to n. So what are we looking for? Well, we're going to try to find f sub 12. Now let's try to find a recursive formula. So if we look at the subset from 1, 2, 3, all the way to n, well, there are 2 cases. Either we have the nth term or we don't have the nth term. So in the first case, when we have the nth term, I'll just write them all out. If we have the nth term, notice that we can't have n minus 1th term or n minus 2nd term, because, I mean, the problem says you can't, this set can't contain one, it can't contain more than one out of any 3 consecutive integers. So the next term that is possible is n minus 3. So we can say that f sub n is equal to f sub n minus 3 plus something else. Now let's look at our second case, where we don't have n. Well, if we don't have n, we can have n minus 1. So this would be plus f sub n minus 1. And so our recursive formula is going to be f of n equals f sub n minus 1 plus f sub n minus 3. Okay, now again, we just need to compute the first few terms of the sequence. So notice that we can have the empty set. So that would be 0 elements. So f sub 0 is equal to 1, because there's only one empty set. Then f sub 1, this would be one way, because, well, actually no, this would be two ways, because we can have the empty set, or we can have the set 1. Next, we want f sub 2. So this would be the number of spacey subsets of the set 1, 2. So this would be equal to, well, we can have the empty set, we can have 1 by itself, or we can have 2 by itself. We can't have 1 and 2, because that violates the conditions of the problem. So that's just going to be 3. Okay, and this is all we need to solve the problem, because our recursive formula says that f sub n is equal to the sum of the n minus 3rd term plus the n minus 1st term. So f sub 3 is going to be equal to f sub 2 plus f sub 0, which is equal to 4. F sub 4, I'm running out of space, but it's fine. It's going to be equal to 4 plus 2, which is 6. F sub 5 is equal to 6 plus 3, 9. F sub 6 is equal to 9 plus 4. F sub 7 is equal to 6 plus 13, 19. F sub 8 would be equal to 28. F sub 9 would be 13 plus 28 is 41. F sub 10 is 19 plus 41 is 60. F sub 11 is equal to 28 plus 60 is 88. And finally, f sub 12 is equal to f sub 11 plus f sub 9, which is 88 plus 41, which is 129. And that's our answer, which corresponds to answer choice E. So I hope that helps you guys understand recursion a bit more. And yeah.